to getting here in the manufacturing world, coming through the movie side. And to start that journey, I was really influenced by the hot rod era, and Hackrod overall was influenced by the hot rod era. Most people have forgotten what it was really about, but the artistry, the ingenuity, and just the sheer balls out culture that it was something that I want to paint a context and a picture for you guys so you sort of understand where we came from. So.
Beyond just cool, the automobile has been a cornerstone of man's ingenuity, mythology, and fascination.
You guys ready?
It magically captures the ideals of freedom and inventiveness that drove us straight into and through a remarkable industrial age. The birth of assembly lines, mass manufacturing, and the Model T Ford put a blank canvas in the driveways of everyday America. At the end of World War II, a generation of Americans returned home with a taste of danger and excitement, along with newfound skills forged by operations of the industrial war machine. Everyday life seemed to run at half speed to these young men and women. They had the power to change this. Regular cars could be stripped down to the bare essentials. And using the mechanical skills learned during the war, motors could be hopped up to deliver high performance to these lighter frames. Soon, all across America, these backyard innovators were redesigning and modifying 30 years of mass-manufactured metal to produce lightweight, stripped down, and incredibly fast cars. Each creation an individual expression of form follows function and aggressive performance ideals.
Now let's move on and join the real speed boys of the desert. At El Mirage Dry Lake, those hopped-up cars may look like a familiar old jalopy, but their innards have been streamlined and given a shot of motorized adrenaline.
The hot rod was born. Hot rodders were the original vehicle hackers. They rescued the automobile from racing into a dull future of generic mass production anonymity by embracing deep customization and radical creativity. They drove what they wanted because they made what they wanted, and they drove fast. What started out as an unruly and dangerous form of racing on the dry lake beds of Southern California rapidly became a highly organized sport of drag racing.
Down to the path, with top elapsed time on our Klondike clocks, a 9.12.
These weekend warriors worked to give their cars any advantage possible over the competition. It was never enough for the average teenage gearhead to simply be fastest. He needed to be coolest. Modifications like the chop top, big and little wheel and tire combos, and stripped down, smoothed out aerodynamic bodywork became de rigueur across America. As young people created their idea of what was cool, with easily accessible raw materials discarded in the junk piles of a rapidly industrialized nation. These mechanical innovators became leading lights in mainstream American motorsports. It wasn't long before the major motor manufacturers were mining this ever-evolving youth culture for ideas and pedaling furiously to keep up with the visual language of the hot rod vernacular.
Hey, you got a bitchin' car.
Yeah, I know.
Somewhere in a place where self-taught mechanics collided with beat culture, the coolest cars on the planet were created in the garages of innovators and makers, changing the car industry forever.
So that's a little bit about hot rodding. A lot of wizardry though, not much CAD, not much data, just feel and artistry. So moving out of that world and into the action filmmaking world, I got a really cool creative brief. And this really started me on this journey towards manufacturing and making things, the future of making things. It was this right here. Everyone's like, what's that? Well, my now partner was running Mattel Hot Wheels. He was in charge of it globally in design, and he wanted to bring the brand to life. I want Hot Wheels for real, mate. And that's a life-size Hot Wheels track with a whole lot of Evel Knievel thrown into it. All right, he said, let's go do this. I mean, it was a tall order, take kids' fantasy and bring it to life. Along the way, we started creating a mythology that there was a mythical place called the Hot Wheels Test Facility, where every car ever made was made by the best engineers with the most cool tech and badass racing drivers, and so everyone really believed it. And we said, all right, let's go do this, and here's what that looks like.
The video is from Hot Wheels. Take a look at that.
For 43 years, this place has been secret.
You come to this facility, this is the cutting edge.
Hold back nothing. The beginning of a whole new era.
It's a kid's dream for all of us come to life. It's man's ingenuity on a grand scale. That's the orange track right there.
The tires aren't gripping. I'm losing traction. Team Hot Wheels. In public for the first time ever.
There have been stories and rumors in the test facility. Time to set the record straight.
I wouldn't believe what I was doing out here.
Unconscious. Got it.
Still no sign of movement in the cockpit.
Guess there's nothing you can't do with a set of Hot Wheels.
So we had a little bit of fun, but we had a lot of risk. And we could have thought we were cool, but instead I said, dude, we're so old school and we really suck. Our margins are thin, we have no tech, we did all of that. From sketch to full build, we built everything you see there in the old school way. And I was like, all right, no more of this. It's too dangerous for my guys, our risk too high. What's going on in emerging technology overall that's gonna change our trajectory? And what about that kid with a dream with a Hot Wheels car in his hand that's dreaming about he wants his own car, he wants his creation? And we started to think about that a lot. And I think as we start to move forward in this talk, the promise of these emerging technologies that all of you brilliant people here are talking about is that somebody with a dream or desire can create whatever they want for themselves. The everyman is going to have the power of large organizations at their fingertips. That's pretty wild. And with that, I started sort of daydreaming, and boom, my next movie was born. It's called Autonomo Part 1, Escape from Detroit. Every movie has a log line, and our log line is, when driving's outlawed, only outlaws will drive. Yes, there's going to be a moment when this war happens between autonomous systems and free man. In our film, at the same time that young kids, entrepreneurs, have the power of Ford Motor Company in their garage, because that's where this is all going, they're building the coolest cars you've ever seen. The next Porsche, Ferrari are being stood up. But you have the opposing trajectory of people who want socialized mobility, ride sharing for everybody, and autonomous systems. Well, we don't think those are going to go together. Humans and autonomous systems in the loop, there's probably going to be a pretty good war that happens, and a rebellion. So it's about the Rebel Alliance sort of fighting for individual freedom. All right, here's the deal. You're going to do the biggest car movie ever with a radical vision of the future of mobility and manufacturing in it. All right, it's tall order. Better have about $250 million budget, probably. I said, no, we need to do this movie for a fraction of the cost. Emerging technologies that we're going to get into should lower our barrier to entry, even in the movie business. So we have to build a lot of cars for this movie. Probably 50 prototypes, ground up design, and these cars need to jump buildings, not be some show car rolling on the thing out of BS. So how are we going to build 50 cars? We have to design up 10 startup brands. I mean, well, we're going to harness emerging technologies. A lot of cool stuff. And part of our model, and as I get into movie to manufacturing, every car and character in the movie will be available on demand from full scale all the way down to 64th scale Hot Wheel. And this movie file to manufacturing file, it's starting to become one and the same. A whole movie is going to be vizzed up in photoreal 3D. Okay, well, when we're going to have data sets, informatics, I'm going to be able to go from my movie design file or CG file over to a manufacturing file. That's pretty exciting overall. So here's the stack that we're looking at right now. You're obviously going to have vision and design, concepting. VR and AR are changing the game radically for us right now. We're building full photoreal cars in VR and running sim. I mean, no more clay models. Our opening image, big ass wind tunnel, used to be $35 million. Now it's $35 a month cloud subscription for flow analysis. So cloud and viz is really changing the game. Reality capture, I'm going to get in that in a minute, because all those hot rodders and all this innovation that's been laid down is sitting there waiting to be ripped. And there's so much great work that's been done that exists. And for small companies, we're not standing on the shoulders of giants like the OEMs. So we're going to have an opportunity. Generative design, you guys are all tracking that. It's going to be a game changer. And then obviously machine learning is going to be there. And all of this digital stuff's great, but then we're going to have to make it, and we're going to talk a little bit about advanced manufacturing and design to product. So here we go. And this was an inspiration for us that really, we were working with Autodesk and envisioning, hey, what's going on with future technology? And everyone's seen this, I'm sure. But we said, holy shit, what if that was a car chassis? What if generative design was applied to like a full-scale automotive chassis? A lot of dynamics there, a lot harder problem to solve than, supporting 300 pounds vertically. But this was a really inspirational sort of piece of business for us. And then boom, you're gonna make a movie, you need a movie star. So we use this car, La Bandita, as our sort of baseline to apply the technologies in our problem to solve. That's the car that we want. A lot of dudes I know want. Nobody makes that car. I can't buy that car from anybody. And I want my own car. So anyway, this car's got a great backstory. It's gonna be a featured character in the movie. And boom, all right. Well, we all start with design intent. Design intent is sort of that inspiration, the purity. All right, well now we can quickly go from sketch to rendering to photoreal model like that, bam, boom. Awesome. All right, well you guys have done some great design work in your lab, but what sits underneath it? What's your engineering? Where's that coming from? Well, that's where this gets pretty fun. So we're gonna move into reality capture right now and ripping reality, because that's been a foundation of our project, is harnessing so much great work that's been done. So now we have geometry. That car was proven world-class race geometry. We scanned it, so we had the geometric model, and we put sensors all over it. I think we extracted like 5 billion analog data points. So then we had a complete data set of the force loads of the car. Data sets, geometry, here you go to the generative design and the AI world. All right, start to go to work. And also we hacked the Tesla, the new motors, Tesla powertrain. So ripped the motor out of a junked Tesla, scanned it, had a 3D model like that, dropped it into our file. So pretty cool overall. But the fact that we're ripping all this information and now letting the generative design engines start to be the equivalent of thousands of engineers working for us. I mean, it's wild, man, like overall. So, but you know what? Sorry guys, got ahead of myself. So, speaking of that, generative design's got radical possibilities overall, and we're extremely excited. So this is a little bit about it, but I want everybody to think about design without compromise overall. Because you're starting with clean design intent, and for my movie, I want my cars to look exactly like they look. I don't want engineering or men to tell me, oh, well, we got to start stomping on your vision, dude, because we can't engineer it, we don't have solutions, and then go to manufacturing and say, we're not tooled up for that, man. Like, so then we end up at somewhere like 20% of like design intent for a working car, and I don't think that's the future. So design without compromise for us starts to be a big, big benefit of generative. So a little bit of generative, a little bit of viz solutions in there. But super cool to see hundreds of variations come up and choose. So I got to get moving here. And this is what she looks like right now. In process, you can see the Tesla batteries and that generative chromoly chassis. So we save 30% of weight off the parent car using same material, same manufacturing with the generative algorithm. Crazy. And I think the aesthetic's pretty rad as well. So this was chromoly to chromoly, once again, 30% lighter. And here's a little example of how we see systems integration working with generative. We have our external void, our ports, and then we start to grow an optimized solution overall. So connecting systems is a big deal. So our motors, shocks, everything are floating. Now we're saying, all right, let's go from electric to gas, and let's make it an off-road car. We have the informatics, the data sets. There you go, new external void to grow into, and let's grow ourselves a new chassis. All right, so everyone's probably going, all right, dude, you're like a movie director up here with a crazy vision. Your other partner's an ex-toy designer. All this digital stuff's cool, but what about going back to atoms? We saw going atoms to bits, going back to atoms. Well, we were fortunate enough to have somebody join our team that's fairly significant, and he's leading our effort to go back to atoms and our overall technical thoughts. So here's a get to know our CTO and a little bit of his vision.
I'm an expert in advanced manufacturing and materials. I've spent my career inventing materials, manufacturing processes for some of the most high-speed products on this planet. And off of it, I was recruited by Lockheed Martin Aeronautics to work in the Skunk Works. I worked in a group that was specifically focused on advanced manufacturing concepts. We were called Project Lightspeed. And we were going to change the paradigms of manufacturing. And my project to enter that group was to study and to determine how we were going to 3D print the next jet fighter with carbon nanotubes. We're looking at a manufacturing future that's going to be very different. In the aerospace world, you have access to a lot of expensive but sophisticated and capable tools. Those tools are becoming more accessible. Those software packages, those imaging techniques, the analysis, even the manufacturing itself is becoming more accessible to other industries, to individuals even. And by taking those tools and offering them to more people, what we're doing is we're democratizing manufacturing. We're democratizing engineering design. We're even democratizing the quality assessment of a finished article. And all of these tools, as they become more accessible, are going to enable people to unleash their own creative and innovative desires. But there's something else that's happening that's very powerful. We're digitizing everything. We're digitizing chemistry, tolerance, measurements, quality, mechanical strength. And once these data become digitized, they can be fed to machine learning systems. And machine learning can beat the world's best chess player. It can beat the world's best Go player. Machine learning can design the world's best complex mechatronic system, no matter what it is, if it has enough data. And what we're doing right now is we're generating the data, the digital inputs that the machine learning systems are going to use to create the next best, optimized for specific requirements product.
So Slade, overall, he set some pretty significant milestones in big metal additive. So he created the multi-robotic electric beam cluster that they 3D printed the propellant tanks for the Orion spacecraft, 46-inch diameter 3D printed propellant tank. So took it from concept to baseline at Skunk Works. So Slade's been thinking about what's the future. That's all great in aerospace world, but like he's saying, what about coming to everyman? So he's pioneered a new big metal additive machine that we are bringing online right now. So aluminum deposition with built-in subtractive milling. So multi-axis aluminum deposition with 5-axis subtractive. And we just completed our first part. Overall, to prove it out, was for the Department of Defense. It was about a 4-foot tall part, and it looks kind of like this. So this was the very first build that we brought online. And having proven out the technology, we're scaling, and we'll be printing aluminum 15 feet by 8 feet by 6 feet with built-in subtractive. And this is an order of magnitude cheaper than powder bed solutions, depositing 3 to 5 pounds of aluminum per hour in an open shop environment. This is pretty radical overall, and a little bit of a glimpse of the future. You know, we could, this part was left crude, part of the demonstration, but the milling could have worked the outsides, and basically you're going to end up with things that look like subtractive billet parts from an additive process. And you know, where that's going, now we can actually say, all right, we're on track for the world's first generatively designed automotive chassis that will be printed full scale in aluminum. And that's, we're online. I wish we were done with it now and I was driving it on stage here, but we got a few more months to go overall. But hey, and the closing overall is the inspiration, where we're headed here for everybody is kids in garages around the world now can dream about big industrial solutions. Like this is powerful, and the everyman is going to be able to have and make what he wants, and that's where we're headed. So thank you guys.